Okay guys, day 2 we are going to look at systems, specifically two special cases. But before we do that, let's review what a system of equations is. Generally, it's just two lines, two equations, two functions, and what you're trying to do, at least for this first week, is just find where those two lines intersect. And wherever this point of intersection is, I'm going to make up this number, I'm going to call it 2, 3. That is the solution to the system. So again, a system is just two or more equations. First year algebra, we usually just work with two equations. When you get to advanced algebra, then we go up to 3 equations, and then we also do non-linear functions. Today, there are two special cases, because most of the time when you're dealing with two lines, this is what happens. This is normal. They cross at some point. But every once in a while, you get two lines that never cross. Like this one and that one. Voila. And the reason they don't cross, obviously, is they're parallel, which means they have the same slope, and they have different y-intercepts. So same slope, different y-intercepts. And in this situation, if they don't cross, what you're going to write is no solution. And then there's one other situation, and it's even more rare than this situation, and it's harder to tell, is when you do this with a ruler. You get one line that looks like that, and then the other line is exactly on top of it. Meaning, or another way to think of it is they're the same line. A lot of people say they're the same line, but it's actually two separate equations, functions. They're just right on top of each other. So this one has one solution, this one has no solutions. This one has an infinite number of solutions. Infinite number of solutions. Because remember, solutions is where the two functions cross, or what points they have in common, and this particular pair of lines, they cross everywhere. Every point they have in common. Real quick review. As long as both of your equations are in y equals or slope-intercept form, it's easy to graph. I'm going to do the first one in blue. The y-intercept is -3 or +3. That's the first point on your paper. And then the slope is 1/3, so you go up 1, right 3. Up 1, right 3. Or you can do the opposite of that, down 1, left 3. Down 1, left 3. The more points you have, the better, generally speaking. And then I'm going to do the second line or function in red. This one, the y-intercept is -3. And the slope is 7/3. So up 7. 1, 2, 3, 4, 5, 6, 7. And right 3. 1, 2, 3. So obviously that is the point that they have in common. That is the solution to the system. So one more thing, and this is important. A lot of students graph the lines. That's great. We're very happy that you graph the line, but you have to tell us the coordinates of this point. And it is 3, 4. Always tell us the x value first, and y value second. Voila, that is the solution to the system. And then we also cover these type of functions. Let me do this one in blue. The y-intercept is positive 2. Slope is 1/3. Up 1, right 3. Or left 1, or down 1, left 3. And x equals -3. So hopefully you guys remember from earlier in the year, x equals is going to be a vertical line. So where does x equal -3? X equals -3 right there. And if you remember, hopefully you remember, you're going to get a vertical line. y equals the numbers will be a horizontal line. X equals will be a vertical line. And it's because every single point on that line, the x coordinate is -3. So x is -3 here, it's also -3 there, and there, and there, and there, there, and there, and there, and there, and there. So where does x equal -3? Everywhere on this line. And that's why you get a vertical line. So I actually think these are the simplest of all systems, because we literally tell you half of the answer right there. We tell you x is -3. So the x value is -3. We tell you half the answer. And the y value is 1. That you wouldn't know until you graph the lines. There's another way you could substitute the value in, but remember, this week we're solving systems by graphing, so we actually need to see you graph 2 lines. Alright, so let's move on to the special cases. The 2 special cases. It's going to be a lot more work. As you notice, the equations are not ready to be graphed yet. You have to get the y by itself first. So got to do a little bit of algebra. So I'm going to do the work down here. Get the y by itself. You want to subtract the x. Subtract x. Cancel. Equal sign should go straight down. Here 2y equals -2 minus 3x. Remember, you can't subtract these because they're not like terms. And then now you divide by 2. Divide by 2, divide by 2. And that cancels, that cancels. So it should take you 2 steps to get the y by itself. 2 or less. And then you actually have to divide both these by 2. -2 divided by 2 is -1. -3x divided by 2 is -3 halves x. We could have changed that to 1.5, but because we are graphing, you want your slope to be a fraction. So let me go ahead and graph that line. The y-intercept is -1. The slope is -3 halves, so you have to go down 3, right 2. Your line should be going down. And the opposite of down 3, right 2 is up 3, left 2, up 3, left 2. Okay, and the second function, -2y plus 8 equals 3x. I'm going to do the work right here because I have a little bit of space. 2y plus 8 equals 3x. Again, the goal is to get the y by itself. So subtract 8 first. Cancel, cancel, equal sign goes straight down. Negative 2y goes straight down. 3x minus 8 goes straight down. And then divide both sides by negative 2. Be careful when you're dividing by negative, guys. Cancel, cancel. Y equals. So 3x divided by negative 2 is negative 3 halves x. And then negative 8 divided by negative 2 is positive 4. Again, be careful when you're dividing by a negative. Red. So the y-intercept is positive 4. The slope is negative 3 halves, just like the first function. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So, because they have the same slope, but different y-intercepts, they are going to be parallel, which means that this system of equations has no solution. So make sure you write no solution. And special case number 2. Again, you can't really tell just by looking at the equations, unless you're a genius. So, you gotta get the y by itself. Let's start with the first equation. 5x minus y equals 2. And subtract 5x on the left, subtract 5x on the right. Cancel. Be careful that not to forget to bring the negative down. So you got negative y equals 2 minus 5x. And then that's a negative 1, so you're going to divide both sides by negative 1. And that cancels that. Y equals 2 divided by negative 1 is negative 2. Negative 5x divided by negative 1 is positive 5 over 1x. I know that 5 divided by 1 is 5, but because we're graphing, you want to leave your slope as a fraction. I graph this one in blue. Y-intercept is negative 2. The slope is 5, 1, so up 5, 1, 2, 3, 4, 5, right 1. And I'm going to do one more point down here. It doesn't quite fit, but it's close. So 1, 2, 3, 4, 5, 1. You only need 2 points to draw a line, but the more points you have, the better. Second equation. Negative 2 equals negative 5x plus y. I'm going to do the work over here because there's a little bit of space. Remember, the goal is to get the y by itself. It doesn't matter if it's on the left side of the equation or the right side. As long as you get it by itself. So in this situation, it's only going to take us one step to get the y by itself. All you got to do is add 5x to both sides. Those cancel. Equal sign goes straight down. Y goes straight down. Negative 2 plus 5x. Can't add those together because they're not like terms. And I'm going to graph this one in red. The slope is 5. If you want to make it into a fraction, put a 1 under it. And at this point, it's pretty obvious that these two lines have the same y-intercept and the same slope, so they are going to be right on top of each other. Negative 2. There's a word for that, but or at least I am not that worried that you know that word. As long as you can graph, which two lines accurately. And in this situation, understand that you're trying to tell us where the lines cross, and these lines cross everywhere, at every single point imaginable. And that's what, when you get to geometry, you learn the definition of a line is just an infinite number of points. So, the answer to this system is that there is an infinite number of solutions. Oops, sorry. There you go. Long video. Hopefully makes sense. If not, watch it over. Email your teachers. Ask questions. And good luck with the assignment.